Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and this is now, I think it feels like video 15 in this series, but I think I'm on video 6 or 7 in this series on analytical geometry, specifically looking at the applications of gradients to parallel lines, and next video is going to be perpendicular lines. So buckle up, hold on tight, this is going to be a bumpy ride. Let's start with the first question. Are the following line segments parallel? Meaning they'll never cross. They can never meet, even if extended to infinity and beyond, they'll never ever cross. How would I know that? Well, the way to know that is by proving that M1 is equal to M2. If it is, then the line segments are parallel. If not, the line segments are not parallel. So let's start by looking at the gradients of the line segment 1. I'm going to go to the gradient formula and substitute in, calculate the gradient as -4/5. Looking at the second one, I'm going to repeat this exact same procedure. And guess what? The answer again is -4/5. Because these two values are the same, we can say the line segments are parallel. Simple and easy as that. But where would be the fun in maths if everything was simple? Oh my goodness, no, I would get bored out of my mind. So what if I give this to you? The line passing through F and G is parallel to y equal to 2x minus 3. Calculate the value of B. Oh my goodness, this is a typical Mr. VG special. A nice exam type question. I want you to hit the pause button and try this one yourself. So how do I analyze a sum like this? Well, I look at all the bits and bobs of information given. The first thing that's given is that it is parallel. So the two gradients must be equal. But which two gradients? The first one is the gradient between F and G. The second gradient I need to get from the line, but I can only get it if y is the subject. But y is the subject. So m, which is the coefficient of x, is the gradient. So what does this mean in the bigger scheme of things? It means the m2, the second m value is 2. I read it off because it's the coefficient of x. In other words, the answer I get as the gradient between f and g must also be 2 because the lines are parallel to one another. So in other words, if I calculate M1 using the formula, I get B minus 2/3. And this must be equal to 2 because the lines are parallel to one another. Solving for B, I'm doing it as a normal equation. Multiplying by 3 on both sides. Solving for B, so B must be 8. Wow, what a fun sum to do. This is Mr. VG signing out. Have a beautiful and amazing rest of your day. If you are still struggling with this, hit the pause button, try it again, and tune in for our next video on perpendicular lines. Keep well. Cheers.